6-8, elimination using multiplication. This lesson is going to be very similar to the lesson we used yesterday where we used addition and subtraction to eliminate a variable. The difference is now, before we can use the addition and subtraction, we're going to have to use multiplication or division so that we can get a term that has the same or opposite coefficient in it. Take, for example, these first three steps we're going to have to start with. Step 1 says you have to multiply at least one equation by a constant to get two equations that contain opposite terms. That's the big difference between this and what we did yesterday. We start off using multiplication, and you'll see how that works in a minute. After that, step 2, add the equations, eliminating one variable, then solve the equation. And step 3, substitute the value from step 2 into one of the equations and solve for the other variable. Write the solution as an ordered pair. Take this problem here. You've got 5x plus 6y equals negative 8. 2x plus 3y equals negative 5. If you look, 6y and 3y have a common factor of 3. So if we were to double the 3, or better yet, multiply the 3 by negative 2, then you'd have positive 6y minus 6y, and these two would cancel each other out, leaving just your x's. But if I multiply the 3y by a negative 2, I have to multiply everything on the left by a negative 2, and everything on the right by a negative 2. And it's going to look like this. This looks a little different than what your textbook set up, and you can see where I took and added some numbers and parentheses in so that your work makes a little more sense. I said negative 2 times everything on the left equals negative 5 times that same negative 2. When you use your distributive property, you get negative 4y negative 4x minus 6y equals a positive 10. These 6's say bye-bye. They have canceled each other out. 5x minus 4y, that's just 1x, or x, is equal to 2. So now we know the solution for our x value. We're going to use that to take and do step 3, substitute the value from step 2 into one of the equations, makes no difference which one you choose, and solve for the other variable. Write the solution as an ordered pair. So you take your original equation of 2x plus 3y equals negative 5. You could have done the other one, but aren't smaller numbers nicer to work with? Plug in a negative 2, plug in a positive 2 that you found right here, and then just work it out. 2 times 2 is 4. Subtract 4 from both sides, gives you 3y equals negative 9. Divide both sides by 3, and now you have a solution for your y value. Y is equal to negative 3. So the solution to a system of equations, the point where those two equations intersect each other, is going to be at point 2, negative 3. Circle or box it. That's all there is to these. Let's try another one. Here you've got 4x plus 2y is equal to 8, and 3x plus 3y is equal to 9. This one's a bit more of a pill because there are no common factors. Your 4x and 3, only common factor is 1. Your 2 and your 3, the only common factor is 1. So in a situation like this, you're going to have to multiply both numbers, or both equations, by a number so that you can cancel things out. Now, if you think for just a second, the least common multiple of 4 and 3 is 12. So I could multiply both sides by 3 and both sides by 4, or one of them would have to be a negative to cancel out, and that would give me 12's here, 12 and negative 12, and they could go away. But the smallest common factor of 2 and 3 is going to be 6. So that if I went for this one, I could have smaller numbers to work with. I could do everything on the top by a 3, everything on the bottom by a negative 2, and they would cancel each other out. To me, using the second approach would probably be the smarter way, but we're going to look at both of them just so you can see that they both would give the same answer. The first approach said to take and multiply everything in the top by a positive 3, and with that, to multiply everything in the bottom by a negative 4. When we did that, we ended up getting 12x plus 6y equals 24, and negative 12x minus 12y equals negative 36. Notice your x values now are going to cancel each other out, leaving us with negative 6y is equal to negative 12. Divide both sides by the negative 6, they cancel out, negative signs cancel out. Our y solution is going to be 2. Now we're going to use that step 3, plugging in, they're substituting 2 for either equation to find the value of x. Take the first equation, I believe. Nope, they use the second equation. Put 2 in for y. 2 times 3 is 6. Subtract 6 from both sides. Divide both sides by 3. And you have an x solution of 1. So this gives you the ordered pair of 1, negative 2, which are not showing here. Should show an ordered pair. Yep, there they did. The solution is 1, 2. Which we need to go ahead and let's put a box around that one just for kicks and giggles to make it easy to see. Right there. And boop, there it is. The solution is 1, 2. Now we're going to do the same exact equation over again. Only this time, instead of multiplying, oh, I goofed on this one. Instead of multiplying both sides by a 4 on the bottom, that we end up doing 3 on the top and 2 on the bottom. So let me take a pause and fix this for just a second. Alright, now this is fixed. I've put a 2 right here, and a negative 2 right here, and a negative 2 on this end. So when we multiply out this time, we're still getting the 12x and the 6y on the top, and the 24 on the top, but this time, the bottom we get negative 6x and negative 6y equals to negative 18. And now my y values are going to cancel each other out, leaving us 12x minus 6x is 6x, 24 minus 18 is 6, which this is going to be a lot happier all the way around. We got positive values to work with, smaller numbers to work with, so really taking the second approach is the easier way to get these done. Divide both sides by 6, x is equal to 1. And then of course you take that x value of 1, substitute it in for the x value of either equation, and find your y value. So take the second equation, since it has a smaller number to start with anyhow, multiply 1 in your x spot. That's going to give you a 3 plus 3y equals 9. Subtract 3 on both sides, going to leave you 3y is equal to 6. Divide both sides by 3, and what do we have? Y is equal to 2. So what is our ordered pair? The solution is going to be 0.12, and that matches the same exact results we came up with for method 1. 2 different ways to skin the same kitty cat. Meow. Your opportunity to expand your mind tonight is page 360, number 7 through 25, and 38 through 48. Odd.
Where is the moment we needed the most? You kick up the leaves and the magic is lost.